Welcome back, students. Today we are going to cover the topic of parallel and perpendicular lines. So parallel lines are going to be lines that never cross. They never intersect. Whether the line is there as it is or if we were to extend those lines, they can never cross or intersect. So if you look at these two graphs, clearly this graph, you have the lines that intersect. They have this point in common. But these two lines, okay, they appear to be the same distance apart everywhere. It looks like even if we were to extend them, they're never going to cross. These two lines are our parallel lines. You can remember parallel has the double L in it. It's because they're going to look kind of like the railroad tracks, staying the same distance apart. Now let's look at the slope of each of those lines. So the line 1 goes down, which means its slope's negative, and it goes down 1, 2, 3 to the right, 1, 2. So this slope is negative 3 over 2. Line 2 also goes down, and it goes down 1, 2, 3 to the right, 2. So its slope is negative 3 over 2. That is not a coincidence. Okay? A property of parallel lines is the fact that parallel lines are always going to have the same slope. Why do they have the same slope? Well, because they'll never cross, which means that they're going to have to move the same way. And slope tells you how to move. So if you move the same way, you're not going to intersect with the other line. Versus perpendicular lines always have to intersect. Okay, now they intersect in a special way in the fact that they're going to form these 90-degree angles. Okay, that's more of the geometry reasoning behind the perpendicular lines. The geometry property is that they'll form 90-degree angles. The algebraic property comes with their slope. So once again, let's take a look at the slope. So line 3 is going down, so it's a negative slope. And it goes down 1, 2, 3 to the right, 2. And line 4 is actually going up, so its slope's positive. I'm not going to put a plus out in front. No sign implies positive. And it goes up 1, 2 to the right, 1, 2, 3. So this slope is positive 2 over 3. Okay, so if you compare these slopes, one of them's negative, one of them's positive. Perpendicular lines are always going to have opposite signs. And notice this is a 3 over 2, but this is 2/3. They have the same numbers, but their position flips. Okay, so what happens is the fraction flips. Okay, so that's the special property with perpendicular lines, is that they're going to have opposite signs and their fraction's going to flip. The technical term for that is going to be what's called opposite reciprocals. All right, so here that is spelled out for us here. So opposite, meaning that they're opposite signs. Reciprocal, meaning that their fraction flips. And that's talking about their slopes. All right, so that's talking about lines that have negative slope or positive slope. Okay, remember there are 4 types of lines, a positive slope, a negative slope, but we haven't talked about horizontal or vertical yet. So let me go over to Desmos. And here I have y equals 5, which if it's just y equals a number, notice it doesn't have an x, which means it's not going to go through the x-axis. It's only guaranteed to go through the y-axis. So if it's going to go through the y-axis, that means it is a horizontal line. Anytime you have a horizontal line, the slope of that horizontal line is going to be 0 over any number. So pick whatever your favorite number is and put 0 over that favorite number. That reduces to 0. Okay, but I'm going to write it as a fraction to make my point. The next line is x equals, which means it's only guaranteed to go through the x-axis. Notice it's missing the y-coordinate, or the y variable, which means it's not going to go through that y-axis. It's going to go through the x-axis at -3, which makes it a vertical line. The slope of any vertical line is undefined. But that's what we get after we simplify. What was it before we simplified? The reason it's undefined is because pick any number that you want, but how far do you move left and right? So it goes up and down, so pick whatever number you want, but then it doesn't go left or right. So it's a number divided by 0. Okay, so notice that these two, even though this simplifies to 0 and this simplifies to undefined, notice that these two slopes are still opposite reciprocals of each other. Okay, opposite meaning opposite signs. So sure, I can make this one positive and this one negative. It doesn't matter. A 0 that's positive, a 0 that's negative is still just 0. But the reciprocals, this was 0 on top, this one's now 0 on bottom. All right, so horizontal lines and vertical lines are always going to be perpendicular to each other. However, we don't really express their slopes as the opposite reciprocals because those slopes simplify to be 0 and undefined. But technically, they are still opposite reciprocals of each other. All right, let's get back to the case of where we have these positive slopes and negative slopes. So sometimes we call those the slanted lines, the ones that are not vertical and the ones that are not horizontal. So if you are given the equation of a line, you are going to want to compare that to y equals mx plus b. And if we are trying to determine parallel or perpendicular, what's important is their slope. So what is the slope of a line? Well, that's your m. So in the formula, y equals mx plus b, we're looking for the m. So in this equation, I have an m of 3 over 2. Any line parallel, remember the symbol for parallel is that double L. So if I see m subscript double L, that means slope parallel. The slope of any line that's parallel is also going to be 3 over 2 because parallel lines move the same way, so they have the same slope. And then perpendicular lines, they are opposite reciprocals. So opposite means change the sign. So both of these are positive, so that means this is negative. And then fraction flips, reciprocal, flip the fraction. So these are 3 on top, 2 on bottom. So this will be 2 on top, 3 on bottom. Let's do another example. If I were to give you the slope is negative 1/4, then I don't have to tell you this, but I could ask for the slope of any line parallel, and you would know that the slope has to be the same, which means that you could tell me the slope parallel is also negative 1/4. But slope perpendicular is opposite reciprocal. So that means opposite, so opposite sign, so that means this is going to be positive, and then flip the fraction, which is going to be the fraction of 4 over 1, which is going to reduce to just positive 4. Let's do one more example. If I were to give you the slope of the line is positive 5, that means any line parallel is going to move the same way, which is also going to have a slope of 5. And then slope perpendicular is opposite reciprocal. So opposite means change the sign, which means that it'll be negative. Reciprocal means flip the fraction. All right, well, we might have a little problem here because these aren't written as fractions. Always put them in reduced form, so I would want to keep this as 5, but to think of the reciprocal, I'm going to write it as a fraction, as 5 divided by 1, or 5 over 1, because this divided by 1 still means I have 5. So 5 over 1 is the fraction. I want the opposite reciprocal, so I have the opposite sign, but now I need to flip my fraction, so this is going to be 1 over 5. So any line that is perpendicular to a line that has a slope of 5 is going to have a slope itself of negative 1/5. Let's continue on the topic of lines and what they are going to be based off of their slopes. So here I'm given 3 lines, and I need to determine if they're parallel, perpendicular, or neither, which means what I care about is determining the slope of each line. So the slope of a line, if I'm given the equation, I need to compare that to y equals mx plus b. So I need to compare this to y equals. So I find the y equals, and then I'll write my mx plus b. And here I'll find my y equals, and I'll write mx plus b. So line 2 is already in the form y equals mx plus b. So determining my slope is just a matter of what's the number in front of x. My m is the number in front of x. That's my slope. So this would be a slope of 1/3. This first line, I have where it has y equals, but notice there's also a 3x. There's this term on the same side as y that needs to be on the opposite side of the equal sign. So to move it to the opposite side, I need to do the opposite. Right now it's a positive 3x. So the opposite of positive 3x would be minus 3x on both sides. So positive 3x minus 3x cancels, leaving me with y equals. And then I put my x term, which is the minus 3x. And then I put the b, which is positive 12. Again, I only care about my m, my slope, because I'm trying to determine what type of lines I have. My slope is the number in front of x, which is negative 3. If I want to write that as a fraction, it's negative 3 over 1. My last line, here I have my y equals, but notice that I have a 2x, which needs to move. So that's a positive 2x. The opposite of a positive 2 is going to be a minus 2. So I'm going to minus 2x on both sides. Positive 2x minus 2x cancels. Notice I still have a negative 6 that's with the y. Equals, I'll put my x term in, so that's negative 2x. And then I have my minus 18. That gets bumped to the end. I want y by itself. This one already had y by itself, but now there's still a negative 6 in front that's being multiplied. The opposite of multiply is divide. So I'm going to divide everything by negative 6. And this is going to leave me with y equals, because the negative 6 divided by negative 6 cancels out. Then I can go to Desmos and I can type in negative 2 divided by negative 6. And that gives me a decimal, but I know I need to convert that to the fraction. That's positive 1/3. So I'm going to write this as positive 1/3. I still need my x. And then my negative 18 divided by 6. Negative 6, sorry. Negative 18 divided by negative 6 gives me positive 3. So that's positive, so a plus 3. So comparing this to y equals mx plus b, again, I only need my slope. My slope of the line is the number in front of x, which is positive 1/3. All right, so now I did the hard part. I did the work. Now I just need to interpret. So my line 1 has a slope of negative 3 over 1. Line 1 has a slope of negative 3 over 1. Line 2 has a slope of 1/3. Line 3 has a slope of 1/3. Line 2 has a slope of 1/3. Line 3 has a slope of 1/3. So now it's just comparing. If the slopes are the same, they're parallel lines. If they're opposite reciprocals, they are perpendicular. And if it's neither of those, then those lines aren't parallel, nor are they perpendicular. So line 1 and line 2 are not the same. So that means that they're not parallel. Are they opposite reciprocals? So is one of them negative and one of them positive? This is negative, this is positive. Yes. Do their fractions flip? So is this 3 over 1? This is 1/3. Yes, they flip. So that means that these two lines are perpendicular. It says justify your answer, so give a reason. So they are perpendicular because they have opposite reciprocal slopes. Now, comparing line 1 with line 3. Line 1 is negative 3 over 1. Line 3 is 1/3. Once again, those are not the same, so these are not parallel lines. Do they have opposite reciprocal slopes? So are they opposite signs? Yes. Did their fraction flip? Yes. So once again, these are perpendicular because they have opposite, which means change the sign, reciprocal, which means flip the fraction, and then slopes. Sorry that looks so bad. You can scroll up above, right up here. That's what I was actually spelling out. Opposite reciprocal slopes. All right, my last comparison, line 2 with line 3, slope of 1/3, slope of 1/3. Those are obviously the same. They move the same way, making them parallel. So that means that they are parallel lines. Why? Because they have the same slope. We didn't get this example here, but had it been a case of neither, would have been something like this. If you had a slope of 1/3 and a slope of negative 1/3. Okay, they have opposite signs, but they are not flipped fractions. So this would be a case of neither. They aren't the same. So that means that they can't be parallel either. All right, now the harder part. Now using the slope of parallel lines or perpendicular lines in order to write equations of these lines that are parallel or perpendicular to the given ones. So to start off, you need the slope of the line. Remember, to write any equation of a line, you need the slope of the line and you need a point on the line. So here we have an equation, and it's y equals 1/2 x minus 7. So compare that to y equals mx plus b, and we can get the slope as 1/2. The number in front of x when solved for y is the slope of the line. So that means the slope of our line is 1/2. That means any line parallel to it is going to have the same slope, which is also 1/2. And any line perpendicular to it is going to have the opposite. So change the sign to be negative. And then reciprocal means flip this fraction, which is negative 2 over 1, and then always reduce. This is the slope of negative 2. All right, so I know this based off of the slope of the line. Now I'm going to use one of these in order to satisfy this, whatever this says. So find the equation of the line that is parallel. So that means I need to use this slope right here. I don't need this, nor do I need this. Find the equation of the line that is parallel to this line and passes through the point. This is the point it goes through. So I'm going to label this as x1, y1. So to write the equation of the line, we are going to rewrite the formula and substitute in our values, which means we're going to erase and replace. So I'm going to erase my m with what I circled over here because it said parallel. I circled the parallel slope, and I'm going to replace it. I'll use a different color. I'm going to replace it with 1/2. I also know my x1 coordinate, so I'm going to erase x1, and I'm going to replace it with x1, which is 4. And then my last one, my y1, I'm going to erase that, and I'm going to replace it with the y1 value, which is -2. Only issue with this, if you try to type this into Alex, is the fact that you have a double negative. You're only allowed one sign, so a double negative changes to a positive. So there is our equation of the line. If the equation was asked to be in slope-intercept form, I'd need to solve for y. But if it's not specified, if it just asks for an equation of the line, here would be my answer. If I needed to solve for y, remember what that means is get rid of parentheses. Parentheses mean multiply, so I'd have y plus 2. I would distribute the 1/2, and I would get 1/2 x. Then I would take 1/2 times -4, and I could use Desmos if I needed for that. I could type in 1/2, and then times that by -4, and I get -2. And then move to get y by itself. Opposite of a plus 2 is a -2. That's going to give me y equals positive 1/2 x minus 4. Okay, so either answer, again, if Alex does not specify what type of an equation it needs, either of these answers is acceptable. I would probably leave it in this form because it's less work to do, but if I need slope-intercept form, if I needed to find the y-intercept, I would solve for y. Our final example is pretty much the same thing. However, now we're looking for slope perpendicular. So once again, we come back up here. The slope of this line was 1/2. So the slope of the line that was given was 1/2. Any line parallel is 1/2 slope. Slope perpendicular is -2/1, which reduces to -2. We, this time, want slope perpendicular. So we don't want this, we don't want this, we want slope perpendicular. That passes through the point for -2. So here's our x1, here's our y1, and here's our slope. So the formula is y minus y1 equals m parentheses x minus x1. So I'm going to erase and replace my m with the slope that I circled over here, slope perpendicular. So I circled perpendicular, which is -2. Then I'm going to erase and replace x1 with 4. And then I'm going to erase and replace y1 with -2. Oh, but that's not allowed. A double negative is going to change to a positive. All right. And if I just need to write an equation of the line, this is it. Here is my equation of the line. The only time I would need to keep going is if it asks for it in slope-intercept form. So if they ask for it in slope-intercept form, here's all we do. We keep y plus 2 for now. We multiply the -2 into the parentheses because parentheses mean multiply. So that's going to be -2x. And then -2 times -4, you can use Desmos if needed, but that will tell me positive 8. And then move the positive 2. Opposite is -2, so move it to the other side. Notice I didn't do that to my x term because this doesn't have an x. So this is going to be y equals -2x. Slope is still -2. Slope is still -2. Slope is still -2. So y equals -2x, and then positive 8 minus 2 is going to give me positive 6. This tells me the y-intercept that crosses through the y-axis at 6. And there would be my final answer. All right, so main takeaway from this lesson is parallel lines have the exact same slope because they move the exact same way. Perpendicular lines always intersect, which means that they have different slopes. How are their slopes different? Well, they have opposite signs, and then their fraction flips. So you'll hear that called opposite reciprocal.